All right, so we continue with consensus model. A key aspect of blockchain technology is determining which user publishes the next block, right? So for this reason, we need a consensus. Note that if there were ever two valid chains presented to a full node, the default mechanism in most blockchain networks is that the longer chain is viewed as the correct one and will be adopted. This is because it has the most amount of work put into it. That is the main reasoning behind that. So, initial state of the system is agreed upon, genesis block. So whenever you design something, you have to start at some point, right? So we call that a genesis block. Of course, if you cheat here, you will lose your people will lose their confidence in your system. For instance, in Bitcoin, Satoshi creates this genesis block and prove that he created that day. Okay. In some cryptocurrencies, designers start the system, but they don't announce it. So from the genesis block, they start pre-mining. So they obtain a lot of cryptocurrencies until, for instance, maybe the 10,000 block. Then they announce it. So this is called pre-mining. So some cryptocurrencies use it so that the designers have some control over the system and so. Users agree to the consensus model. Every block is linked to the previous block by including the previous block's headers hash digest. Users can verify every block independently. This is the important thing. You can go and verify everything that is written in a block. So, consensus model. Software handles everything and the users do not need to be aware of these details. And actually, this is why nobody knows how these things work. For permissionless blockchain network, the consensus model must work even in the presence of possibly malicious users, since these users might attempt to disrupt or take over the blockchain. Note that for permission blockchain networks, legal remedies may be used if a user acts maliciously, because since if it is permissioned, you give the permission to some people, so you know their identities and so on. So if they behave in a bad way, maybe you can take some legal actions and so on. This is why, consensus models are somewhat different in permissioned and permissionless blockchains. A key aspect of blockchain technology is determining which user publishes the next block. We can use different consensus models for that. We have things like proof of work, proof of stake, round robin, proof of authority, proof of identity, proof of elapsed time, proof of storage, and so on and so forth. So there are many methods. So for instance, in the proof of work, you show that you use your computational power to solve this problem. But of course, this consumes a lot of electricity. So in the proof of storage, you again do some computations, but store it in your hard drive and prove that you are storing them in your hard drive. So you don't consume that much amount of electricity, but of course you waste that storage by storing some unnecessary data. So there are many different ideas, like you share your Wi-Fi, and depending on how much you share that, you can, earn cryptocurrency and so on. So there are many different consensus models or mining algorithms, let's say. In the proof of work model, a user publishes the next block by being the first to solve a computationally intensive puzzle. The solution to this puzzle is the proof they have performed work. The puzzle is designed such that solving the puzzle is difficult, but checking that a solution is valid is easy. This is very important, because sometimes you can make the problem harder, but if it also makes the checking harder, then you cannot use it. And this is what happened in Litecoin, actually. They tried to design a puzzle where no ASIC can be built, but people started building ASICs, so they increased the difficulty of the puzzle, but increasing that difficulty also makes it harder for people to validate it. So at some point, they had to stop and admit that, yeah, the people can build ASICs for this problem, okay? This was in the case of Scrypt mining algorithm, if you're interested, which requires actually some huge amount of memory, so that people thought that it will be harder for ASICs to be built. But we have ASICs for this Litecoin example. This enables all other full nodes to easily validate any proposed next blocks, and any proposed block that did not satisfy the puzzle will be rejected, because it is easy to check. A common puzzle method is to require that the hash digest of a block header to be less than a target value. This is what most of the cryptocurrencies use, actually. For example, Bitcoin, which uses the proof of work model, adjusts the puzzle difficulty every 2016 blocks to influence the block publication rate to be around once every 10 minutes. This is important because initially you determine the puzzle difficulty. So assume that there's only one miner, Satoshi mining, but then maybe 10 people also start mining. So this time, in the Bitcoin, we wanted around 10 minutes to take place so that we can write a block. But now, if you have more power, you will solve this puzzle faster, right? So in the example I gave, most probably it will take only 1 or 2 minutes to solve this puzzle. But in every 2016 blocks, the software looks how many minutes it took for the whole miners to solve these 2016 blocks. And if it is, faster than the expected value of 10 minutes, the software automatically increases the difficulty. So this way, if you keep the mining power the same, it will take around 10 minutes again. But if you include more miners, this will increase again. But if miners leave the system, it will take more than 10 minutes to solve this problem. So 2000 blocks later, the difficulty might be decreased. So some people think that difficulty always increases, but this is not the case, okay? It increases if there are more mining power. If the mining power decreases, the difficulty also decreases. And this happened a lot in the past, okay? Some people are surprised to hear this, but this is what happened. So 2000 blocks, think that it takes around 10 minutes for a block to be written. So if I'm not mistaken, this 2000 blocks corresponds to 2 weeks of time. So every 2 weeks, you update the difficulty of the Bitcoin. The proof of stake model is based on the idea that the more stake a user has invested into the system, the more likely they will want the system to succeed, and the less likely they will want to subvert it. Stake is often an amount of cryptocurrency that the blockchain network user has invested into the system through various means, such as by locking it via a special transaction type, or by sending it to a specific address, or holding it within special wallet software. Once staked, the cryptocurrency is generally no longer able to be spent. Proof of stake blockchain networks use the amount of stake a user has as a determining factor for publishing new blocks. Thus, the likelihood of a blockchain network user publishing a new block is tied to the ratio of their stake to the overall blockchain network amount of stake cryptocurrency. So you stake some cryptocurrency, for instance, Ethereum moved on to proof of stake last September. You stake your money and you earn cryptocurrency, generally around 4%, and you keep your money there. So this time we don't say that these people are miners. Now they're delegators, okay? And in order to do it, actually, normally when you use a blockchain, you install the software and you keep a copy of the blockchain, right? Miners now install mining software. For the case of proof of stake, you need 3 software, one for the Ethereum blockchain, one for staking, and one for being delegator, okay? In being delegator, you actually approve this blocks when somebody, tries to write it, okay? So, and when Ethereum actually moved into this system, when you stake your money, actually you are not allowed to withdraw it because they are moving into a new system. So they wanted to, see if the system works. So in the next update, you will be able to withdraw your money. So if I'm not mistaken, in a few days, that update will be activated. So people who stake their money since September, now we will be able to withdraw it. So this is important because, this might affect the price of Ethereum because you don't know if when people are allowed to withdraw it. Some people think that everybody waited like months, so now they will withdraw all of their stake money. But this is not a reasonable argument because those people who stake those money are generally in it for the long run. So most probably they will keep using it, okay? But, These are just speculations, and so we don't know how it will affect the price. Okay, but just be careful when just check, when the update becomes effective, if you are interested in this kind of stuff. The methods for how the blockchain network uses the stake can vary. Some approaches, random selection of stake users. So this is a nice idea, but question is how the random selection works, because how you can prove that you really randomly created a random number. Okay, so there were some ideas. Some people decided to build special hardware which are tamper-proof and generate random numbers. Nice idea, but never works in practice. You can do multi-round voting, coin aging system. In the coin aging system, once in order to do the staking system, they have to be old. You cannot just use the newly minted mining system, newly minted coins, and so on. So there are different ideas here. For instance, in the coin aging, it depends on how old the coin is so that you can use it, and so on. Also, delegate systems, and again, there are many variants. Currently, as far as I know, there's no well-written document explaining how Ethereum proof of stake works. Okay, we have some explanations. We have the software, but actually we don't have a good academic paper which explains everything. So I hope in the future we can have it so that I can include in the slides actually. Regardless of the exact approach, users with more stake are more likely to publish new blocks. So rich becomes richer. This is one of the arguments people have. But also this applies for mining, because if you have rich, you have more, you can buy more hardware and earn more, and so on. So there's a comparison again from this document. So here are some of the algorithms, advantages and disadvantages, and generally where they are used. So in the case of permissionless, think about proof of stake. Advantages are hard to perform denial of service by flooding network with bad blocks. Disadvantage, power consumption. This is why Ethereum moved from proof of work to proof of stake. Bitcoin consumes a lot of electricity, but compared to banking system, it is still something for me acceptable actually. Hardware arms race. People who are buying new hardware, become. This actually creates a new area where you are building new hardware and people buying new hardware. So people also ask this, that hardware only performs mining. So question is, why are we using that electricity and that hardware, those resources? Because, people think that this is unnecessary. But in order for system to work, we have to play the game in this way. 51% attack by enough computational power, if your mining power is more than 51%. But again, if it is not 51%, but let's say it is 47%, you can still perform this attack, but your success rates will not be, probability 1, close to probability 1, but maybe 0.9, which means that you can still perform the attack. Proof of stake, less computation, stakeholders control the system. This is an advantage, because stakeholders who are invested in the system control the system. But also this is a disadvantage, because stakeholders control the system. If you have enough financial power, actually you can control the system. In the 51% attack here, this attack depends on your financial power. Okay. And possible centralized power, because stakeholders can get together. So if a few rich people can get together, they can perform this kind of 51% attacks. So we are moving on to permissioned systems. Round robin, less computation, easy to understand, requires trust between publishing nodes. This is the disadvantage. Proof of authority or identity. Here we know the identity of the people who have the authority to write the blocks. So this is fast and dynamic block production. Anybody can write directly there. But the problem is that centralized point of failure. For instance, if somebody just a private key of some authority leaks, they can just perform many attacks and so on. Proof of established time. Less computation advantages, but the disadvantage is that you need a hardware to measure this time, and hardware may be compromised. And this happens many of the time. I mean, we have many special hardware in our CPUs or in many devices which are used to store keys or randomly generate numbers. But we have seen many, sometimes direct attacks, sometimes side channel attacks, but it is not that easy to design such a hardware and keep it safe. Let's talk about ledger conflicts and resolutions. It is possible that multiple blocks published at approximately the same time. This happens many times in Bitcoin or Ethereum in the mining case, but of course, Ethereum is no longer proof of work. This can cause differing versions of a blockchain to exist at any given moment. This must be resolved quickly to have consistency, right? Conflicts temporarily generate different versions of the blockchain. Conflicts are usually quickly resolved. Many blockchain networks will wait until the next block is published and use that chain as the official blockchain, thus adopting the longer blockchain. Here, as you can see, I didn't use the word fork, and this is not a fork. Okay, this is just a conflict. And here in the Bitcoin, for instance, as a miner, you solved the puzzle, but somebody else also created a block at the same time. So if their block becomes longer, then your block becomes orphaned, and so you don't earn any money. In the Ethereum, these blocks called not orphaned blocks, but called uncle blocks, and they also receive some amount of Ethereum because they did some work. So and in the Ethereum, the block addition time was a lot shorter than Bitcoin. Instead of 10 minutes, it was around 20 or 30 seconds. So it was more easy to have uncle blocks there. This is why Ethereum actually, rewarded them with Ethereum when it was proof of work. But nowadays, of course, it is proof of stake, so it's no longer valid. But this way, you can, as a miner, solve a problem. But if that block becomes orphaned, this means that generally you don't receive any reward. Yes, I said that was a conflict. Now let's talk about forking. Changes to a blockchain network protocol and data structures are called forks. A soft fork is a change to a blockchain implementation that is backwards compatible. Non-updated nodes can continue to transact with updated nodes. This is what a soft fork is. Okay. A hard fork is a change to a blockchain implementation that is not backwards compatible. So when you do this update to the system, those nodes who did not update their system cannot understand what you are talking about. So at that point, actually, you create a parallel universe. Updated people work on a different blockchain, and non-updated nodes work on the other one. Okay. It is important to note that while most hard forks are intentional, software errors may produce unintentional hard forks. Okay, so here we say it is generally intentional because, for instance, you want to create a new cryptocurrency, but you don't want to do it from the start. You can say that, okay, for instance, 100,000 block of Bitcoin, I will create my own cryptocurrency, just copying the Bitcoin blockchain, but now I'm changing some of the parameters, so my blockchain will be something different. This is sometimes a nice thing because at that block, people who have Bitcoin will also have their Bitcoin in your new blockchain, right? So this way you don't need to, need some measures to invite people because they will already be in your blockchain and they can use that system. So this kind of intentional blockchains happened a lot, but sometimes some software error may produce an unintentional hard fork. This happens mostly in smart contracts because a smart contract, people write their own software. So a smart contract running on every different software should give you the same output. But if you make an implementation error in your software, a smart contract may work on some nodes in a different way. And this happened in the past. Okay, this is just a programming error. And this way you can create unintentional hard forks because when you run the smart contract, the output might be different where you run that smart contract as the software. Okay, so this is why sometimes unintentional hard forks occurred due to programming errors, actually. With cryptocurrencies, if there's a hard fork and the blockchain splits, then users will have independent currency on both forks. This is what happens when you create a fork for Bitcoin, and Bitcoin Cash is an example, or in the Ethereum Classic is an example. When you create that fork, for instance, if you have 2 Ethereum at the time of the fork, you have 2 Ethereum and 2 Ethereum Classics. And in the Bitcoin, you had, for instance, if you had 10 Bitcoins, you had 10 Bitcoins and 10 Bitcoin Cash. So this is somewhat important for the value of the cryptocurrency, because at that point, you don't know which one more people will adopt, right? Because the people adopt become more expensive most of the time. So some people thought that when you divide Bitcoin as Bitcoin and Bitcoin Cash, some people thought that more people will be in the Bitcoin Cash world, so that the price of Bitcoin will drop and Bitcoin Cash will be higher. But those people who know the system will confident that, Bitcoin, since it is, legacy of Satoshi, they thought that it will be the winning blockchain. So when the fork happened, everybody sold their Bitcoin Cash with a high price and, converted them to Bitcoin. A nice way of becoming rich, this kind of forks, if you know what will happen after this fork, okay? If flaws are found in the cryptographic technologies within a blockchain network, the only solution may be to create a hard fork, depending on the significance of the flaw. So in the past, this happened. For instance, assume that you have a cryptocurrency, but your mining algorithm is the same as the Bitcoin mining algorithm. So most probably only a few people will be using your cryptocurrency, but there are a lot of miners for Bitcoin. So those miners can stop mining Bitcoin, come to your system and perform a 51% attack and destroy your cryptocurrency. In such a case, you have to modify your algorithm. So you have to change your mining algorithm, right? So in this scenario, you have to create a hard fork. Okay. Sometimes this is what it means. If flaws are found in the cryptographic technologies, in some cryptocurrencies, there were some errors in the mining algorithm. Some people realize it and contact the designer saying that mining algorithm is false. So there are flaws in the mining algorithm. I mean, their aim was to mining puzzle to be solved in 2 minutes, for instance, but you could instantly provide solutions. So this way you can destroy the system. So for this reason, if you are changing the cryptographic algorithms, you should have a cryptographer in your system. So this is why, when people try to design cryptocurrencies, they always try to have a cryptographer as a consultant and, take advice. Yeah, some short info about smart contracts. Smart contracts extend and leverage blockchain technology. A smart contract is a collection of code and data that is deployed using cryptographically signed transactions on the blockchain network. The smart contract is executed by nodes within the blockchain network. All nodes that execute the smart contract must derive the same result from the execution, and the results of execution are recorded on the blockchain. A smart contract can perform calculations, store information, expose properties to reflect a publicly exposed state, and if appropriate, automatically send funds to other accounts. Okay. Although we mentioned this in a single sentence, most people are actually interested in these properties and writing smart contracts and having different abilities. Note that not every blockchain can run smart contracts. Okay, it depends on the programming language the blockchain supports and so on. Yes, let's talk about limitations and misconceptions so that we can understand when we can use a blockchain. So people say that a blockchain is immutable. Actually, it is tamper evident and tamper resistant, because as we have shown the examples, we can, if everybody agrees, we can go back and modify something. Ethereum Classic hard fork is an example of this. And for example, competing chains change this immutability. 51% attack also, breaks this immutability. In the permissioned networks, you can have a misconduct. Since they have the authority, they can misbehave. But of course, this can, lead to legal implications. But in all of these scenarios, we can modify the data in the blockchain. That is what we are thinking. So we are saying that this is not immutable. but it is tamper evident and tamper resistant. Another thing is the beyond the digital problem, the oracle problem. So this is important because we want to use the blockchain technology and map it to some physical things that happen in the world. For instance, you want to sell your car and in return obtain the cryptocurrency for it. Assume this is the scenario. So you can receive the cryptocurrency on the blockchain, but you have to physically give the card to that person. That is what we call the oracle problem. You cannot be sure, I mean, by writing software, we cannot be sure that that card is really given to the person, right? So you have to map it somehow. So this is what we call the oracle problem. And most of the time, this is what people are missing. So this is also happens in the e-voting. People think that if we write the votes on the blockchain, they say that, you know, we can prevent misbehavior, right? But here the problem is that writing the votes to the blockchain, if it is, I mean, you are transferring as something physical data to, you know, digital data. If at that point you trust that the physical results are correct, so that you write it into the blockchain, right? If you assume that it is correct, then there is no behavior that you can, you know, correct anyway. So you start with the trust and then write it to the blockchain. So you have to be sure what the problem is and what the solution is. So you have to be, you know, familiar with the limitations and misconceptions. This is what we are trying to say, right? So oracle problem is a important problem. I mean, you have to somehow map the physical world to the digital world so that you are sure that something happened in the physical world. So this is why you are transferring that amount of money. Okay. Of course, there are some good ideas, some solutions, but depends on the problem. Yeah, another misconception. We say that there is no trust in blockchain, so we don't have to trust anybody. This is a misconception because we trust a lot of things anyway. So there is no trusted third party for certifying transactions, but there is still a great deal of trust in the cryptographic technologies utilized, which nobody knows, by the way, but you know, people need to know. And we have trust in the correct and bug-free operation of smart contracts, which might have unintended loopholes and flaws, which they have most of the time. We also have trust in the developers of the software to produce software that is as bug-free as possible. But a simple bug in Java version of Android for random number generation actually ended up with people losing a lot of Bitcoins. Okay. So there is a trust, but if there is a fault in that trust, then, you know, it doesn't work as we expected it to be. Most users of the blockchain are not colluding in secret, so we have the trust that this is not happening, so they're not come together. If a single group of individuals can control more than 50% of all block creation power, it is possible to subvert a permissionless blockchain network. So here, what we are trying to say is actually important. Nowadays, for instance, for the case of Bitcoin, you can buy a hardware, but your mining power will be very small compared to the total mining power. So this is why you actually join a pool and you work with others. And there, at some point in time, a pool actually reach more than 50% of the whole computational power, I mean, all mining power. So people who actually realized this left that pool and moved on to other pools so that this 50% attack idea should not be, you know, performed, you know. But this is actually not still a solution. So assume that a pool has 30% of the mining power and the other pool has a 30% of the mining power, right? So in total, they are actually 60%. So we are talking about two people who have designed these pools, right? So they can in secret collide and, you know, obtain a 60% power at the end. So here we are actually still trusting some people that they are not misbehaving. Similar thing can happen in the proof of stake scenario anyway. So for blockchain network users not running a full node, there is trust that nodes are accepting and processing transactions fairly. So sometimes, for instance, if you install a wallet software or anything on your mobile phone, this means that you are not actually storing all of the blockchain on your mobile phone, right? So when you're working or checking some transactions, actually you need to ask the full nodes. So here you also trust them. That is the idea. So this table became famous. I created my own, but then looked at, I created a very similar to this one. So NIST uses this one. Also, it is used in many documents in the United States. So ID is as follows. Let's have a flow chart and ask some questions. So at that point, we want to decide if a blockchain might be useful or not. Okay, so people try to use blockchain for every possible problem they have, but it solves none of them, because after 15 years of Bitcoin, we still don't have fantastic blockchains that people thought that it would be. We don't go to the internet and download blockchains and install on our laptop, because it solves very nice problems like cryptocurrencies and some maybe NFTs and that kind of stuff might be nice ideas, but it doesn't solve all of your problems. So question is, in what kind of scenarios I can use it? So in order to see if a blockchain might be useful, you have to answer yes to all of these questions. So let's start with them. So first question is, do you need a shared consistent data store? And a lot of people who consulted me, they wanted to design a blockchain for their company, but it turned out that they actually don't need a shared and consistent data store, because they were only the persons that are going to write data to it, and they weren't planning to show it to other people. Then the question is, why then you want to use a blockchain? And they say that blockchain is hype, so we thought that it would be useful for us. So most of the time it fails at this question. So if the answer is no, you can just use email, spreadsheets, database, whatever you want. Does more than one entity need to contribute data? This is also important. If you're only the person who is contributing the data, then most probably, you don't need a blockchain. But maybe at this point, if the answer might be no, but there might be auditing. Maybe you have to show to government that you are doing it correctly. So even if you are the only person who is contributing data, if you need auditing, then we can say this yes to this question and move on. Data records, once written, are never updated or deleted. If no, your answer is no to this question, you can simply use databases, right? Another question is, sensitive identifiers will not be written to the data store. This is also important. Whenever I see ideas for blockchain users, they say that we will write, Zoom communications to blockchain without taking any permission from the people or any other sensitive data, like names and social security numbers of people and so on. You cannot do it here, because since they think that it is related to crypto, and they thought that when you write it to blockchain, nobody can read it. But as we have seen, it is publicly available data storage. So if you write something here without encrypting it, and if it is a sensitive data, then it will be a problem. So you have to say yes to this question, saying that sensitive identifiers will not be written to the data store, as a plain text, of course, here what we are trying to say. The next question is, are the entities with write access having a hard time deciding who should be in control of the data store? This is also important. For example, if you have like 3 people who can contribute to data, but if you trust each other, then most probably you don't need to have a blockchain. You can use managed database and that kind of stuff. Finally, do you want a tamper-proof log of all rights to the data store? If again, yes, and yes to all of this question, we say that you may have a useful blockchain use case, but this doesn't mean that blockchain will solve this problem anyway. You have to come up with the solution at the end anyway. So this is why blockchain is not that that's used like machine learning, because there are many hype topics like Internet of Things, machine learning, big data, blockchains. These are all hype topics like metaverse, NFTs, Web3. But we have many products that use machine learning. So they will be around more than, we will see more examples after ChatGPT and so on. But for the blockchains, we have to wait for some people to create a really nice idea and use it so that we can use it, right? We have maybe thousands of examples for nice machine learning ideas and use cases, products, but we don't have that amount of blockchain around. Okay, so I mean, it solves the cryptocurrency problem, but what other problems it solves that we couldn't solve with other technologies stays an open problem. And they're actually huge. I mean, we can do a lot with blockchain, but we haven't discovered it yet. That is the question. But in order for us to discover it, we have to understand what the blockchain is and how it works. But in order to understand it, we have to understand all of these technologies it uses, and one of them is cryptography. And people don't want to learn it. This is why people came up with strange ideas which actually doesn't work in practice. This is what I'm trying to tell.